We have Syed MUDASIR, who is going to be talking about introduction to Docker, and I leave the floor to Syed to take up the session right now.
Good afternoon, everyone. Let me introduce myself. My name is Syed MUDASIR. I'm certified Kubernetes administrator and certified Kubernetes application developer. I regularly delivers the things on maybe the broadcast, the webinars, the trainings on the containerization technology. Okay, let's get started with the containerization. I think you can able to chart. Okay, so before getting started with the topic, let me ask some question. So the question is, in the past, in the history, how we actually host our application? What is the destination? Anyone, any answer? If you have answer, please write it in the chat. Okay, so let me tell you the answer. The answer is we actually host our application in past directly on bare metal server. So which is directly on infrastructure. So what is the problem with that? So the main problem by hosting, if you host your application maybe on bare metal server, the main problem is you can't able to host multiple application on a single server. And you can't able to scale your application. Every time you procure the instances for every businesses, so you need to procure a big, maybe on based upon the guess, you need to procure a big instance for every business. You end up paying a lot of cost, huge money, and it will cost you a lot. And after some time, maybe in 1990s, in 2000, so the problem is we usually host our application on bare metal server. Everyone is happy, not that much happy, because they need to pay huge cost. For every business you need to pay huge money. And after some time, so this is how the bare metal server look like. So yes, the bare metal, this is how the bare metal server look like. And so the main disadvantages with the bare metal server is you can able to host one application per server, and then it is more expensive because for every time you need to pay huge money because you're hosting your application directly on server. And mismatch of capacity for every business. When the business arrives, you need to guess what are the different things you needed, lot of stuff, and then the maintenance of those server is expensive. After some time, we think that it is not a suitable technology to host our application, to digitalize our application, to go with the IT, lot of stuff. So after some time, somebody came to market and is telling that, hey, I have a solution by using which you can able to run your application on a single server. You can able to run your application, maybe multiple application on a single server. Any guess, anyone? What is that solution? You can write it. You can write and write the answers in the chat. Any guess? What is the solution by using which we can able to host our application? Which technology rectify the problem? Okay, so I can't able to see the chart, the support team, how to get access to chart. Yeah, let me tell you the answer. So the answer is the VMware, the virtualization. The virtualization is a solution by using which you can able to host multiple application on a single server. So what is this virtualization? What is this technique? Virtualization is the technique of virtualizing the underlying infrastructure such as memory, CPU, storage, all the stuff. Everyone is happy. Everyone started using this technology because it is kind of a boom to whole IT industry. So in just and in almost overnight, the world changed into a much, much, much better place. We finally had a technology that allow us to run multiple application on a single server, which means multiple businesses on a single server. wild celebration. Everyone started adopting this technology. Everyone is happy. Everyone migrated from the infrastructure to the virtualization. Fine. So what is this virtualization? Already discussed, it's a technique of virtualizing the underlying infrastructure such as memory, the CPU, and storage. Fine. And how the virtualization technology will look like? Let me show you that. So the virtualization technology is, we get started with hardware. We need this layer at any cost. The second is operating system. And the third layer is hypervisor. What is this hypervisor? This is a solution they invented to run your multiple application on a single server. By using this technology, we can able to run multiple businesses application on a single host. Any guess, anyone? What is that solution we got? That's where the VM, the virtual machine, comes into picture, by using which we can able to host the smallest deployable unit in virtualization world is VM. What is this VM? Anyone? Any idea? So the virtual machine is nothing but it is a virtual environment that functions as virtual computer system with its own CPU, memory, network, interface, and storage. So this is how your virtual machine will look like. Its own guest virtual hardware, its own guest operating system, your application code, your application binaries, all in one server that is called virtual machine. Now I can able to run two application on a single server, two businesses application on a single server. This is my application 2. For that application, I need different guest virtual hardware, guest operating system, and the application binaries and libraries for that specific application. Now, I don't have to procure two servers. I can able to run my application on a single server itself. Fine. Everyone is happy because they can able to run multiple applications on a single server itself. Okay, so what is the solution we got? By using which solution we can able to run multiple application on a single infrastructure, single server? Hypervisor. This is the guy who changed the whole world into new place. By using this technology, by using this software, we can able to run multiple applications on a single server. Fine. So what is this hypervisor? Let's dig more and let's understand what is this hypervisor. So the main job of hypervisor is it allow one host computer to support multiple applications, which means multiple guest virtual machine by virtually sharing its resources such as memory, CPU, and storage. In the market, we have two types of hypervisors. One is type 1 hypervisor, which run directly on top of hardware. Type 2 hypervisors, which runs on top of host operating system. In the type 1, we have different examples like KVM, Zen, Hyper-V from Microsoft, ESX and ESXi from VMware Workstation. And in the type 2, we can have Oracle VirtualBox, VMware Workstation. Yes, these are some of the examples for type 1 and type 2. Why we are discussing all this stuff? We need a kind of a flair why we are moving to containerization. That is the only reason why we are understanding what is this hypervisor, how the things works here. Okay, this is how in the market we have two types of hypervisor, type 1 and type 2. Type 1, which you can call as bare metal hypervisor, which runs on top of hardware, and type 2 is the hypervisor which runs on top of host operating system. So why they have two types? Type 1 we usually prefer to use in production scenarios, whereas type 2 we prefer to use for testing and learning purpose. Fine. So everyone is happy because they got a new solution by using which they can able to run multiple application on a single server. And this is very good technology. Now also we are using this. Okay, so after some time, so after using this technology for maybe more than 2 to 2.5 decades, we think maybe we need some maybe kind of some fast technology by using which we can able to host our application maybe in more effective way. So the main problem with this virtualization, I can't say the problem. So the way how we deploy our application in virtualization world is we need a whole guest operating system, and that guest operating system which making my application hectic. Okay, so this is how, these are some of the drawbacks with the virtualization. VMs are great, but they are far from the perfect. Each guest operating system will have its own kernel and set of libraries and binaries, which means, so my intention is to run my application, to see my application is running in running state, but I need to install whole operating system, whether it is small application, whether it is big application. I need to install whole operating system, and in that guest operating system, I need to pay licensing charge for that. I need to patch, I need to upgrade, I need to ensure there is no attacking surface at the operating system level. So these are some of the drawbacks with the virtualization. We felt maybe after some time using this technology for more than 2.5 decades, we felt, so if we had any technology with minimal rather than whole operating system, if we able to run our application with minimal, what we need with minimal operating system, it would be great. So when you know the problem, there is somebody already maybe thinking of that problem, and he may working behind the solution. So that's where, so when we think this is the problem, this may be the problem, so somebody already invented the solution. Any guess, anyone, what is that solution? With minimal operating system, I can able to run my application. Any guess? So that's where the containerization comes into picture. So what is this containerization? Containerization is the method of operating system level virtualization. So here, I don't need whole operating system to run my application. How? MUDASIR, is that possible to run your application without operating system? No. How? Then how the container is achieving, how the containers running? So the containers leveraging the properties of kernel, the leveraging the properties of maybe what are the things needed from the kernel, they are leveraging those things from the host operating system. Rather than having whole operating system for every application, here in the containerization, when you go with containerization, they are leveraging those properties from the host operating system. Here, I don't need a whole operating system or guest operating system for my application. No guest operating system overhead, and it utilizes a host operating system. Okay, so how this containerization will look like? So let me show you that. So the first layer is nothing but hardware, host operating system, and this is what the solution they got: container runtime interface. Like hypervisor, we have a generic word in containerization, that is container runtime interface, and in that we have Docker, Containerd, CRYO, CRICTL, the CRYO, and then RKT, Podman. So like that, we have different technologies by using which we can able to run our code, our logic inside a container. So this is how your container will look like: app1, app2, app3, app4, app5, and then app6. Here, I don't have to go with whole operating system. What are the things needed to my application to see my application in running state? Those are the things I will add in my package in my application code and remaining things like kernel properties, all the stuff related to operating system, I'm going to use from the host operating system. Okay, so MUDASIR, what is this container? So how the container will look like? So you can think of a container is same idea of a physical container. So think like a box, and inside a box you have application. And what is your application? Your logic, everything. What are the things needed to see your application in running state? You will add all this stuff inside that container. And you can think of computer. So my computer in the sense the hardware. On top of hardware you have operating system, any operating system like Ubuntu, Fedora, Debian, and any Linux, different Linux flavors. And on top of that you will install the CRI, Docker. Okay, on top of that, if you want to run your application, this is how the things look like. Appen, so running inside a container, and every container will have its own host name, IP addresses, and its own disk size. You can able to tell what are the things needed to your application. You can able to configure how you configure in virtualization world for VMs. You can able to configure same thing in here in the containers as well. App1, app2, and then app3. Okay, so this is how the container will look like, and inside your container you have your application. And so what is the difference between the virtualization and containerization? So the virtualization, here we have same layers, the hardware, we need hardware layer this at any cost. On top of that, the host operating system. On top of that, the hypervisor in virtualization, and CRI in containerization. If you install a hypervisor, so that will become the virtualization. You need to go with VMs. If you install the Docker, you need to go with containers. Fine. So now we have a very good idea what is this hypervisor. Here I need guest operating system to run my application. In containers, the containers leverages the host operating system capabilities from the host operating system. They don't go with whole operating system. They don't need guest operating system. Okay, fine. And what is the difference between the virtualization? You know, so what is virtualization? It's method of hardware level virtualization, and each VM needs its own guest operating system. That's where my application has become quite hectic, larger in size, dedicated kernel. Each VM will have its own libraries and binaries. Each VM, and it's because of a whole guest operating system, it will take more longer boot up process, take more time for creation, and consumes more resources. Whereas in the containerization, it's a method of operating system level virtualization, and the containers take a help from the host operating system. That's why your containers, if you run your application inside a container, they will be in smaller size. They will take help from the host kernel. They will take help from the host for libraries and binaries from the host operating system itself. That's why you can able to spin your application in Docker world, in container world, maybe in some seconds. And if you want to migrate your application from one host to another host, it will be a very easy job at the container world. Fine. So we are good. I think we are good about the virtualization, the bare metal server, and how the Docker solving the problem. So that's why now this containerization, the containers, the Docker, the Kubernetes is a buzzword. Everyone started adopting this technology because everyone want to host their application inside a container, because it will be much faster. Because in this era, you need maybe faster technology to handle your application. So the main guy name who is helping to host your application is Docker. Yes. So what is this Docker? how the Docker helping to see your application in running state. Let me show you that. Let's talk about Docker. What is Docker? How the Docker works? What are the different terminologies you need to know regarding the Docker? When you hear a word Docker, you can think of two things. One, the name of the company is also Docker, and the technology name is also Docker. And the main job of Docker is it's an open source platform for developing, shipping, and running your application. All the things you can able to achieve with the Docker. You can able to develop your application, you can able to ship your application, and you can able to run your application. All the things are taken care at the Docker level itself. And the main problem we usually face in the production is my application is running in my laptop, not in the prod server. The Docker solves that problem as well. Here, the Docker giving the capability of packaging your application to the developer itself. He will package, he will add all the stuff, what are the things needed for his application in the Docker file, and that package will be handed over. The package in the sense that zip file, that executable will directly hand it to the prod guy, and you can see the same what you see in your laptop in production server as well. It will run in the same way. You don't have to worry about it should work in my laptop, it won't work in prod. Docker enables you to separate your application from your infrastructure so you can deliver your software very, very, very quickly. That is also another big problem the Docker solves. And the third thing is Docker. The main job of Docker is to manage the life cycle of container. So in the sense, creating, deleting, editing, working with the containers, all the stuff are taken care by Docker itself. You can able to manage the life cycle of container, editing your application, executing some commands, pausing, unpausing, deleting, everything is taken care by Docker itself. Fine. And the use of containers to deploy your application is called containerization. If somebody tell you, hey, we have containerized our application, the meaning of that is those applications running inside a container. Fine. And let me talk about little boring history about the Docker. The Docker technology is the Francisco-based technology company, is invented by the Francisco-based technology-based company, and the guy name is Solomon Hayes, who invented this technology. He's a French-born American developer and entrepreneur. And how the Docker word comes, if you know dock workers, the guys who load and unload cargo ships, the containers from the cargo ships, we called them as dock worker. They took that word and they take maybe the 4 letter from the dock, and from the worker they took last 2 letters ER. They named this technology as Docker. And this is how the interesting the fact about how the Docker name came. Fine. So it is kind of developed using Linux core components in 2013. And if you want to work with the Docker, you need to know some of the terminologies. So in Docker, for everything we have, we usually manage our maybe application by using different components. Mainly, you need to know some of the component, some of the things in Docker. If you want to start, there are 3 terminologies you need to remember at any cost. When you want to start your application, maybe when you want to containerize your application, if you are planning to run your application inside a container, in that scenario, you need to start your application. Maybe you need to start the things from the concept called Docker file. So in Docker world, you can think of Docker file is kind of a recipe, is kind of maybe the thing where you specify everything related to your application, like which operating system, on which operating system your application depends on, what are the things needed, what are the binaries needed, what are the different OS constructs needed, on which port your application will listen on, where your source code is present. All the stuff we will tell inside a Docker file itself. Okay, so the result of Docker file will be, when you run that Docker file in the Docker environment, you will get one executable, you will get one template that is called a Docker image. What is the Docker image? So you can think of Docker image is a maybe kind of a maybe binary that includes all of the requirements for running a application, running your application. What are the things? Maybe it includes everything that is needed to running your application, maybe your application code, any software, which application depends on, and any other configuration. All the stuff you will add inside that package. You can think of that package is a Docker image. And what is this container? So Docker container is just a run instance of that image. Docker container is a run instance of that image. Let me show you how the Docker file will look like, how the Docker image will look like, all the stuff. So so if you want to know, so where I can get these images, how the Docker. So there is one repo, one registry named Docker Hub. You need to know this. So this is where you will get all the containers related images. So like, just name some softwares like maybe NGINX. You will get to see the images there. Okay, how many pulls for this image? 1 billion plus. This is a Docker official image. This is the free image. Just click on this. You will be routed to the information, the more information regarding this image. So who is maintaining, how the stuff, or here itself, you will get to see the Docker file, the recipe of this image. This is what I'm talking about, the Docker file. If you see here, so this image is kind of maybe by using some of the Docker file instruction, I'm telling that on which, what is the base operating system for this image, who is maintaining, what are the environment variables, what are the packages needed, all the stuff I'm telling inside my Docker file. You can think of the Docker file is kind of a recipe on which for this application will listen. Like that, you can search all types of images. If you want maybe CentOS, you will get the image for that as well. If you want MySQL, yes, name the software, you will get that software, MySQL, the MariaDB, the PHP image. Okay, so you will get all the types, all the container related images in the Docker Hub. What is this Docker Hub? You can think of it as centralized registry where the Docker is managing all the open source images here. Fine. So this is regarding the Docker image, and then Docker file, and then Docker container. Let me revise the stuff. Docker file is kind of a recipe where you need to add all the stuff, what are the things needed to your application, like on which base operating system your application depends on, what are the things, what are the environment variables, what are the arguments you want to supply, where your source code, and where you want to copy that source code. Yes. And when you run that Docker image in the Docker environment by using Docker command, say Docker, I want to build an image by using this Docker file. You know, Docker file is kind of a recipe. You have added all the stuff, what are the things needed. Then Docker looks to that Docker file and it will package all the stuff in one executable. That executable is called Docker image. And by using that Docker image, I spun my application and with n number of replicas based upon my cluster resources, based upon my host. You can able to run infinite number of application by using that image. So this is regarding what are the different terminologies we talk: Docker file, Docker image, and Docker container. And let me show you the other thing as well. Yes, how the Docker works. So you can think of, usually when you think you want to build your own application, you want to start building your application, the starting point is Docker file. You need to start, you can think of it as kind of a project code where you have everything, and the result of Docker file is Docker image. When you run the Docker file in the Docker environment, that is Docker image, and you just test whether the Docker image is behaving as expected or not, whether it is in that scenario. And then Docker, the result of, by using that Docker image, I spin my application inside a container. And then when you find everything is fine regarding that image, you push that image to Docker Hub. What is this Docker Hub? It's a centralized where you are shipping your application, where you ship your images. From there, your prod guy, your staging guy pull those images and test your application in the staging server, and then they deploy that application in the production. So this is how the things works in the Docker. Anyone, any doubts? Let me know in the chat. Any questions? Is the Docker Hub open source? Yes. Yes, Sunil. Yes. So if you want maybe more classes, more things, maybe you need to reach to Spring people. This is how the things will be covered. Maybe this is what you need to know regarding the Docker world, maybe kind of an introduction. Yes, thank you so much, everyone.